right, so let's play out this research example we've talked about already with regard to the listening to music while you're studying and exam scores. Because I think that'll give you a clearer example of how you might design something. And let me go and throw it out there too. This might be a really good way to kind of outline your thesis research as you start to brainstorm. I think it's really good to start with an outline in terms of research. I'm not usually an outline kind of guy, but I think once you get the idea rolling using this example or like the vignette that I provided on Blackboard, I think that really helps you to lay the design out a little bit better and kind of put your thoughts in action a little bit more. So let's start out with hypothesis, and actually even before that, I didn't include it on here, but even before that, let's start with the research question, right? So in this case, my research question would be, do students who listen to music while studying and taking tests outperform students who don't, right? That's my question. Research question is a question. I'm asking a question. As we talked about on the hypothesis chapter, hypotheses, however, are statements. So how would I answer my research question? My hypothesis would be students who listen to music while they study and take the exam will do better than those that don't, right? Precise, detailed, testable. It meets all three requirements, and as I said, it is a statement, not a question. I'm hypothesizing that they will perform better because they were listening to music through headphones while they studied and while they took the exam. So that's my hypothesis. My independent variable in this case, so what am I manipulating? We've already talked about this on the previous slides. I'm manipulating the music aspect, right? So whether or not they listen to music while studying and taking an exam. So in this case, I would actually have two different conditions, two different groups, as it were, right? I would say, okay, one group will listen to music while they study and take the exam. The other group will not listen to music while they study and take the exam. The operational definitions can get more precise after that, right? So am I going to make them listen to the same music, right? So am I going to control for that? Do I control? So if I say, okay, everyone who's in the music condition has to listen to Beethoven, and it's going to be this symphony, right? And so they all listen to the same thing, or they're all going to listen to Beyonce, and it's going to be these songs or these albums or whatever like this, right? Do I control that? If I control that, it makes a difference in terms of how the study will play out. Likewise, do they listen through their own headphones? Do they listen to music with like through a stereo at home and then listen to the headphones while they take the exam? So they might seem like little details, but as you of course know, the devil is in the details. We have to decide: are they going to wear headphones like the Beats by Dre style that cover the ear, or the Skull Candy style earbud style that actually just go into your ears? For some people, they have a strong preference. I don't like the big ones that cover your ears. It makes me feel kind of hot and claustrophobic. But the earbud style ones, some people don't like. So we need to make sure we control these things and think of what it would actually look like. Don't just say they're going to listen to music. That's a good start, but you have to think of the details that go into that. What music? What are they all listening to the same music? What volume? Is it all the same volume? How long? Right? All sorts of factors that can really impact the study that are quite detailed. Your dependent variable too, this is a little bit easier to pin down, I think, right? So you want to be consistent. So ideally, both groups would do the same, get the same sort of test. So what I would suggest is if we were doing this, we could do this in a general psych class over a unit test, not a final exam, but a unit test, right? So that covers 2 or 3 chapters. Both groups take the same test. I would not make it an essay test. I would make it a multiple choice test. I also wouldn't make it particularly long because then we could start to see exam fatigue set in and mess up with scores. So I would say maybe 30 to 40 questions, multiple choice over a couple of chapters that have just been covered, right? And once again, I can't just, you might just say, oh, well, they're going to take a test and I'm going to compare test scores. You need to be more precise than that. What kind of test? What style of test? How long will it be? Do they have a time limit? Are they taking it together? Any number of details that you might think are inconsequential, but actually can make a big impact on how the study, what conclusions you can draw. The design we'll talk about a lot more in this course, but the design is mainly focused on the sample. Who are you testing? If I was to do this at HBU, for example, with my undergrads, my general psychology class is actually over 90% non-majors because everybody has to take it. It's a general ed requirement. So, you might think, oh, well, we want a good representative sample. Well, in this case, actually, it is a good representative sample because it represents almost every major on campus because it's not predominantly psych majors, right? Size-wise, how many people do we want in this study? I would say at least 100, so 50 and 50, but we could even go bigger. If you were at a state school, for example, you could do, some of these general psych sections have like 200 or 300 students in it. Do the whole section, do as many as you can, right? But still maintaining representativeness. And let me return to this point. Representativeness is more important than the size of the sample. Both are important, but representativeness is the most important. Within the design section too, you want to think of the procedure. So what time of day are they taking the exam? Is it a Scantron exam? Are they taking it on a computer? Are they actually circling the right answers on a piece of paper? Have they seen some of the test questions before? Was there a study guide? Right? All sorts of factors that the researcher really needs to document, not least of all so that people can replicate the study. Sampling and assignment. So in this case, there wouldn't be random sampling, and we'll talk more about sampling in subsequent lectures. But in this case, we couldn't have random sampling. As desirable as that is, we're actually just utilizing students who are in the course, right? So we're not randomly sampling anybody. These people are in the course already, so there's nothing random about it. They're actually more of a convenient sample than anything, but they are representative, right? They are representative, which is nice. We would, however, make sure to randomly assign them to either the music condition or the no music condition, and that would allow our study to still fall in the region of full experiment as opposed to just a correlational study. Confounds. Whew, doggies. There's going to be a lot of confounds for this, right? Let's start with this note. Anything that you don't control has the potential to be a confound, right? So if you say, okay, I'm going to let them listen to whatever they want. All right, that's a confound. I'm going to let them use whatever headphones they want. All right, that's a confound, right? All sorts of things that we don't control for can be confounds. But there's also things like test anxiety that we can't control for. How do you make people not have test anxiety? Well, you don't. Even saying, don't worry, this will be okay, don't be scared, you'll do just fine, in some cases that's going to ratchet up the anxiety. So you have to kind of keep that in mind. Let's see, other things to consider. The temperature of the room that they're taking the exam in. As I said, the time of day, time of year. Have they eaten lunch? Is it early, right? What other things are going on? Is it during a pandemic? Because that's impacted how people perform on their exams altogether because of the stress and anxiety associated. Always think about the confounds. Statistical procedure, I've talked about this in a subsequent lecture, or previous lecture rather, excuse me. We want to make sure that whatever we are designing, we know how we intend to test it, what statistical procedure we intend to use, because we cannot just simply guess after the fact. We have to make sure that we're getting the appropriate data for the appropriate hypothesis, right? We can't, if we say, there's going to be a significant relationship between X and Y. Okay, we're running a correlation. Oh, there's a significant main effect between X and Y. Well, then we're going to run an ANOVA. We have to keep in mind when we posit a hypothesis that we have to be able to address it later on, as the slide says, testable. So how are we going to test it? Make sure you think that through as you go. And what I would say, if you're outlining this, for example, for your own thesis, which I would strongly recommend, you might find that you're going from top to bottom, but you get about 3 steps in, and you're like, oh, wait, no, I got to go back and change this now in light of this. That's fine. Write this in pencil or do it on your computer so you can go back and copy and paste, cut and delete, whatever you need to do, because I guarantee you the design will not be written in one single go. You have to go back and say, okay, well, now that I've got this piece in place, I have to go back here and address this, or I have to add this detail. So just kind of keep that in mind. It's a very iterative process. I'd invite you to start it now because it's actually really important that you get the ball rolling in 6320 so that 6324 and 6199 can go much more smoothly. So as I said, detailed, explicit, very, I'm trying to think how to describe it, realistic sort of research design. Think of what it's going to look like if you are in the room while the participants are testing. And then to kind of close here too, there's another piece of data from this particular source here. We've got a headline, scientists say eating butter can save your marriage, right? In this case, we're correlating divorce rate in Maine with per capita consumption of margarine, right? Obviously, eating butter is not going to save your marriage, but what they've found is that people in Maine tend to get divorced less frequently in years where there's a lower per capita consumption of margarine. So make sure you eat that butter. And if you're interested in more of these examples here, this is actually from a book named Spurious Correlations by Vigan, I suppose it's pronounced. I invite you to look it up. He's got a good website too. It's just full of these sort of things that really drive home that point that correlation certainly does not indicate causation.